In the last video, I explained to you how an increase of developmental gene regulatory networks created disparity. How it did that. But another similarly interesting question is why? Why did disparity, why did the shapes and forms of animals start to explode? Or in other words, what is the cause of the Cambrian explosion? You can create new shapes and forms using genetics, but why would you do it? What was the driving force? Evolution is only doing things that seem to be an advantage. So some questions for you. What is proto-Hertzina? Why is it so important? And why does it remind you of Freddy Krueger in The Nightmare of Elm Street? Name an example of an arms race between modern predators and prey. Think about the Serengeti or the Kalahari, if you will. Give me two examples how prey responded to the evolution and emergence of predators such as Sanctacaris. 4. What were the ecological consequences of the evolution of very sharp focusing eyes? The evolution and the emergence of eyes, what did it do to the world? Now, the cause of the explosion. I tell you straight out what it is. The Cambrian explosion is the result of an escalatory co-evolutionary arms race between predators and prey. It's important. This is an ecological effect, not a genetic effect. It's an increase in the complexity of individual organisms and of entire ecosystems based on the interaction between different creatures. I'll give you a number of examples to make that clear. It all started really with this pretty horrible fossil up there called Proto-Hertzina in the very earliest Cambrian, or the even more fearsome looking Mongolodos. These are microscopic, but look, this is razor sharp stuff. And not too long ago, they found out what they are, because there is modern counterparts that look like that. So these are not fossils. These are from living creatures. But you see just how immensely similar these things are. And these are chaetonaths or arrowworms. And they look really fearsome, although small, like that. That's a chaetognath. That's a chaetognath, and this is the entire animal. It's tiny, but if you're a small creature, this is a big, fearsome predator. And creatures like that were probably responsible for driving the Ediaca biota extinct. You know, there's creatures like Dickinsonia and Chaniodiscus sitting on the ocean floor, being soft, made of jelly, having no armors, no teeth, very slow, cannot move away. And then a monster like that comes along and nibbles on it and eats it. That's it. So the Ediaca biota probably went extinct because someone started to eat them. Creatures like Proto-Hertzina drove soft-bodied Ediacans to extinction and started an arms race towards armors and spine. And so you can probably now understand what the small jelly fossils are that we discussed in the very first hour. You see here from the Tomotian all sorts of creatures, all sorts of little shells made of phosphate that look like pieces of armor plates or spines or claws or cones and shells. This is clearly someone who tries to protect themselves. How did that happen? Well, once we have teeth and jaws and claws, someone doesn't want to be eaten. So the prey evolves spines, for example. This is Wyoaxia. It's probably a mollusk-like, a snail-like creature, and it has all these amazing spines. So nothing coming from above can eat it. The same with Hallucigenia from the Burgess Shale of the late Cambrian, middle Cambrian, sorry, these beautiful spines here. It didn't want to be eaten. Then we have really fearsome predators like Sancta caris. That's probably the precursor of sea scorpions and modern land scorpions. It could not swim yet, as far as I know. It was creeping across the surface of the seafloor looking for food. So what did prey do to avoid being eaten by Sancta caris? I give you two examples of strategies. Strategy number one is quite simply, well, you learn how to swim, like Odorrhea. You see here, this beautiful fossil is Odorrhea, and this is a reconstruction of Odorrhea swimming. So if Sancta caris comes creeping along the seafloor looking for food, Odorrhea is just going swoosh and swims away. Alternatively, you can, rather than going up, you can go down. So we have here Otoya, which is a preapulate worm or penis worm that is digging into the sediment. So it has its head sticking out, looking for food. When Sancta caris comes along it goes and retracts itself into its burrow. But every invention and every evolution of prey will create an arms race amongst those predators to get against it, to become yet one step better. So if a creature like Otoya learns how to burrow, some predator is going to learn to have a snorkel-like long mouth to get into the hull to get to the food. That's exactly what we see in the most amazing Burgess Shale fossil called Opabenia. Opabenia doesn't only have 5 eyes on its head, it has, as you can see here, a long snorkel of a mouth with a claw at its end. What on earth is that? Well, Opabenia was probably sticking this thing into holes to pull out worms. That's an arms race. The most fearsome predator of the Cambrian was almost certainly Anomalocaris. And if you have seen the documentary with David Attenborough, Early Life, and if you have not seen it yet completely, go on YouTube and watch it. You must do it. It's amazing. He talks a lot about Anomalocaris. What is that thing? Well, this is half a fossil. The lower half is missing, but this is the upper body. Here you can see things it can use, paddles it can use to swim or breathe, gills. That thing here is the head. This is the left mouth, left claw with sharp spines. And this is the other claw. And oh my God, do you know what this is? This thing and this thing? These are eyes on stalks. And the reconstruction of Anomalocaris looks like that. Now, look at that thing. Big eyes on stalks. This creature must have had awesome vision. It had an acute, sharp sight of its prey. That's quite typical for predators. Think about eagles and cats that have extremely good eyes. What would that do with evolution? Maybe the evolution of sight was one of the single most important thing for the Cambrian explosion. Because if you can be seen as a prey, you must adapt, avoid being seen. And if you're a predator who can see, you can create 1,000 new strategies how to find food. That's beautifully summarized in the next picture. Now, look at this. We have here Anomalocaris with an acute sense of vision, an eye. Here it is just eating a trilobite. And what you can see here, well, can you see adaptations against being eaten, against being seen? Well, these things here are sponges. And creeping around in the sponge is Aischia, which is a charming little velvet worm. Aischia has adapted the color of the sponge because it doesn't want to be seen. Then can you see somewhere here in this picture Otoya, the preapulate worm? No, you can't see it. It is hiding. It's burrowing in the sediment. But there's also other adaptations. For example, here is Morella, the first creature on my favorite t-shirt. It is drawn here in blue and red very beautifully. We do not know this. We don't know if it had color, But it's obvious that sexual attractiveness was really enhanced by being colorful. Now look at this. So the evolution of ice has a lot to account for in the rapid evolution of different shapes and forms. And if it's just trying to look pretty. Now the Cambrian arms race creates a network of ecological interactions, which is shown here for the Burgess Shale in a very simplified form. At the base of the food web, we have the food, algae. Then we have grazers and filter feeders eating them. Then we have scavengers eating dead creatures and predators, and up here, top predators, eating everything else. Every creature that evolves in this network creates a new niche that drives other creatures to adapt to it. There's a new grazer, so there will be a new predator trying to eat it, and there will be a response from algae and other things to protect themselves. I show you now real networks created from fossils from the early and middle Cambrian. On the left, we have such a network constructed for the Shenyang biota from China. You can see at the base are primary producers and an increasingly complex network as we go up towards the top predator. Not much later, in the middle Cambrian of the Burgess Shale from Canada. This network, if you look at the number of lines, the number of interactions between creatures, this has become an immensely complex ecosystem with a lot of different niches and a lot of different organisms that can evolve into that. In the next video, we are going to discuss why the Cambrian explosion is unique and it never happened again.